All right, so today we're in section 7.5, analyzing and sketching graphs. Okay, so I handed out your notes, and this notes handout is also uploaded in your Google Classroom notes section for chapter 7. All right, so in a nutshell, and I already said this, so we're just going to kind of go over it again. Graphs can show the relationship, okay? So whether it's increasing or decreasing or staying the same between two quantities. In this case, it would be distance and time. But here's the key for the whole lesson. You're not going to see any specific numbers on your x-axis or on your y-axis. So I don't care how much time. I don't care if it's been an hour or 2 hours. All I'm doing is just looking at the trend in the values. Okay, so let's see what this looks like in example 1. In example 1, I want you to describe the changes in temperature in Belfast, Maine, and in Newport, Oregon. So what you're going to do is you're going to look at this graph for Belfast, Maine. Okay? Obviously, the x-axis tells me time throughout the day. The temperature, the y-axis, tells me how the temperature is changing throughout the day. So for Belfast, Maine, what happens to the temperature at the start of the day? What's happening? It's increasing, right? So that's what you would put into a statement. The temperature in Belfast, Maine. All right, so we'll just say Belfast. Okay, I'm going to have to kind of write off to the side. All right, so for Belfast, Maine, the temperature increases at a pretty constant rate. To start the day. Then what does it happen at the top of the line? Is it just a sharp decrease? Is it like it just stops and then it immediately? No. Then the rise in temperature slows down, right? It starts to kind of level off. Slows down. And then declines or decreases. So all I'm doing is just describing what's happening on this line. Okay? It increased, then it kind of started to level off, and then it decreased. And isn't that how it should normally happen in a normal day, right? When you first wake up, it's cold, then it warms up. Then around 3, 4 o'clock, the temperatures kind of level off, and then they start to decline when it gets nighttime again. So look at Newport, Oregon. I want you to try to write what's happening to the temperatures in Newport, Oregon. Okay? So obviously we have a different trend in the data here for Newport. What's happening to the temperature? Okay? So I want you to do Newport now. Can anyone give me their explanation of what is happening to the temperatures in Newport, Oregon? What's happening here? Anyone? What do you think? Starts off, and what happens to the temperatures in Newport, Oregon? What, Sabrina? The temperature decreases. That's what I said. The temperature decreases or it drops at a constant rate in the morning at the start of the day. Then what happens? Austin, then what happens?
It starts to stay at the same temperature.
Stays the same. Then it levels off. It stays the same for a while. Does it tell me how long it stays the same? That doesn't matter. All I need to say is it stays the same or it levels off for a while. Then what happens? Then it increases later in the day. Okay? So, again, were there any specific numbers? No. All I'm saying is the temperature drops at the beginning of the day, then it levels off, then it increases at the end of the day. That's it. Okay? So you don't have to have the exact explanation that I just wrote. As long as you're telling me, morning or what time of day type thing that starts off in the morning, levels off, and then warms up later in the day. That's fine. Did you guys write something similar to that on your papers? Yeah. So let me ask you this. What could be an explanation for the decrease in temperature and then the increase in temperature in Newport, Oregon? Because again, that's not typical. What we see as typical is what happened in Belfast. So what could be an explanation for this drop-off in temperature in Newport, Oregon? What do you think? What could be a potential explanation that at the beginning of the day, instead of warming up, the temperatures actually drop off? Kaylee? It could, it probably is winter. Yes, Marcus? Yes. It's snowing. There's a storm. Right? Has anybody ever come to school and when you got to school, it's like whatever temperature, but then when you get out of school here in Jacksonville later in the day, it's actually colder? You guys, we have days like that, don't we? Where it actually, as the day goes on, it gets colder because there's cold fronts coming in. There are storms coming in. So something along the lines of that a storm came through the city. Causing the temperatures to drop. Now, here's the tricky part. Is there any math formula that could tell you that answer? No. So that's where the analyzing comes into play. You have to give me a reason. Could you have had a different reason than that? Well, it is weather, so it probably does need to be weather related, why it would get colder. Okay? But you've got to think. You got to put on your thinking caps with these. All right? So now I want you to try one. Look at the path of the pelican. We have a vertical distance, that's his height in the air, and then a horizontal distance or a walking distance. You could think of that as ground zero. I want you to describe the path of the pelican, what's happening as far as his flight pattern goes. Okay? And then try to write an explanation for the decrease in the vertical distance. All right? Go ahead and work on this. I'm going to give you about 2 or 3 minutes to work on this. All right, so William, what did you say?
I said that he starts out high off the ground.
Uh-huh.
And then he slowly decreases in height.
Yep.
Until he's almost at ground zero.
Very good. So that's kind of what I said too. I said he started at a slow decline, then a sharp decline, then he kind of leveled off. Okay? I saw some people said he swooped down. I love it. Okay? Because that's a flight pattern, right? You can tell he's kind of declining and then he really swoops down more towards the ground. Okay? So what could be your explanation for that? Why would he be flying and then all of a sudden he swoops down like super close to the ground, William?
He could have seen some food.
Seen some food, right? He's swooping down to grab a fish out of the water. All right. Marcus, what did you put? All right, so maybe he's like flying and he like runs into something. And then, and then he's like obviously going to decline after that. I had some other people last hour say that he was landing. Did anybody say he was landing? Perfect. Okay, so don't erase what you wrote just because it's not exactly what I wrote. There's so many different answers. But does your pattern describe a decline, okay? Because his vertical distance declined and then it started to level off. That's all you have to say. That's it. My explanation was he was looking for food. Your explanation could have been he was landing, or he ran into something. Whatever. How are we doing on this? Okay, so now you're going to sketch your own graph. Okay, so now you have the explanation. You're going to sketch your own graph. Well, you have to start off with labeling each axis. You know you're going to have a horizontal axis and a vertical axis. The best advice I can give you here is that your vertical axis is the value that's going to be changing up and down. Does that make sense? So one of your categories is just going to be, it's just going, right? But then another category is going to be the one that's changing up and down. I want you to try to label. There's going to be two categories here. All right, I want you to try to label each axis. So go ahead and set up your X and your Y axis. What do you think they're going to be labeled? What do you think they're going to be labeled? All right, any guesses on the X axis? What would you label the X axis? Any guesses? The horizontal axis? All right, so let's read it. It says a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop at the next station. Sketch a graph that represents this situation. All right, so answer me this. What is changing throughout this problem? What is it? The speed. So speed is my vertical axis. Speed is my vertical axis. Okay, well, where's it going? It's distance, right? Distance is my horizontal axis. All right, or how far it's traveling. I'd say you could say time also. Time could have been the horizontal axis. So you start off at 0. No distance, no speed, okay? So from this point, so you're going to start off your line in this bottom corner here. How should your line start off? Should it start off straight across? Is that what the problem is telling you? What does it say? It says that it gains speed at a constant rate. So just write a gradual line. Now, your line might go higher than mine on the graph. That's fine. As long as you're showing a gradual increase. All right? And then, what does it say next? It travels at this speed for a while. So what kind of line would represent that? Just a straight line across. It travels at that speed for a while. All right? Just a straight line across. It's kind of hard to do on my iPad. So there we go. That's my best effort. Then it slows down at a constant rate until coming to a stop at the next station. So how could I write that line? Just going back down. Okay? And actually it needs to go all the way down to the bottom because it came to a stop. Okay? So the speed has to be 0. So do you see what we did there? It increased, then it leveled off. Stayed at that speed for a while, and then it slowed down until it came to a stop. So that's why the end of the line had to touch that bottom line, showing a speed of 0. That's it. You say, well, my line angle different. That's okay. That's all right. Because again, there's no numerical values on the axis. It doesn't tell you how fast. It doesn't matter. You're just showing the trend. All right, how are you guys doing on this? Doing okay? All right, example 3. Now we're just going to compare. It's just a comparison between the two. Runner A and runner B. I want you to tell me what you see by the red line. What is happening with runner A's speed? Sorry, the vertical axis here is distance. So I need to write that distance here. Okay, so this is distance. All right, so that means the top up here, this is like your finish line up here. Okay, this is distance. This is how fast they're running it. So I want you to tell me, what do you see about runner A's speed? I want you to write that into a sentence, what you see happening with runner A's speed. Go ahead and write that. Me, what's happening with runner A? What happens with runner A's speed? Obviously, they're both running, so their speed is going to increase. Anybody tell me what happens with runner A? Want to raise your hand? Tell me, what do you think? What do you think for runner A? Speed what? Increases at a constant rate. All right, so he's going good. Then what happens to runner A's speed? Levels off. He maintains that speed, so then it levels off. It stays the same for a while. Then what happens to runner A's speed? Then it increases again. Okay? Oops, did not mean to hit that button. What did I just hit? Nope, didn't mean to do that either. Hold on. Okay. All right, so what do you see happening with runner B? Tell me, what do you see? Runner B's speed what? Increases gradually. Sorry, I don't know what happened with my slide here. Actually, I do. Here, let me see if I can. Okay. I think, nope, I still messed it up. All right, speed increases gradually. Then what happens? So he's increasing, but then what happens? He like really turns it up, right? Because it's going like straight up now. So for runner B, then his speed, he speeds up. At the end, even more. All right, that's runner B. Sorry, I don't know what I did to my screen. This is runner B. Okay, so runner A, his speed increased, then it leveled off, then it increased some more. Runner B, he was increasing, but then he really sped up. So what do you think, who do you think wins this race? If the line can, yes, runner B wins this race. Because if the line continues to trend the way that it's trending, he's going to finish this race in a shorter amount of time. Look here. So, I mean, he gets to the final distance here, but runner A, this is time down here. So he finishes it in a shorter amount of time than runner A. We don't know how much shorter because there's no numbers, but that doesn't matter. Okay? So runner B finishes the race faster. Yeah, unless they ask for an explanation, which they don't really. Okay. All right. So that's really what your homework is tonight. Is just to describe what's going on, the relationship between the two quantities. That's your first 8 problems out of 9, 10, 11, 12. You're sketching 2 on your own. All right. So there's really no math to do on tonight's homework. It's just a matter of reading what's happening. Increasing, staying the same, decreasing. All right, so let's go ahead and open up Big Ideas and let's get started on our homework. And that's everything you need to know for 7.5.